Hi, everyone. All right, so I'm going to, this is going to be a recording of myself going over the homework assignment, which was on Test Wizard, right? So matter, energy, and mixtures. All right, so here we go. Let's just dive right in. I'm going to annotate the questions. I'm going to go over the questions in detail. And so be patient. It's Friday. It's the Friday before Halloween. It's like 4:30-ish, and it's been a long, very long week. So patience with my explanations. I'll try to make them make more sense. Okay, so let's get started. So number one, which statement describes a chemical property to distinguish a compound A from a compound B? So whatever I choose, I have to be able to use it to distinguish two compounds that I don't know the identity of. Just by looking at something and saying A is blue and B is white, okay, I can distinguish the two, but that's not a chemical property. That's going to be physical. Melting point and boiling, melting point, low and high melting points. Melting point is a physical property. Remember, a physical property doesn't change the identity of the substance when it undergoes the property, but a chemical property does. When you dissolve in water, A and B, they're not going to change identity. It's just going to be dissolved in water. Again, so dissolving is a physical process. Does anytime you see this word burn, always a chemical property. So that's going to be D. All right, so which substance cannot be broken down by a chemical reaction? So that is the definition of an element. And when I'm looking for an element, I'm either looking for one capital letter or I'm looking for something that is listed on table S of your reference tables. So since I don't have symbols, I can't do my capital letter thing. So I need to go and I need to look at everything on table S. I'm going to scan for the word ammonia. I don't see it. It's not an element. I'm going to scan for the word, and by scan, I mean read carefully and search carefully. It's a big reference table. It's 2 pages, lots and lots of stuff on there. Methane, not on table S, right? Ammonia is a compound then. Methane is a compound then. Antimony is on table S. It's the symbol SB. Okay, so that one looks good. And water is a compound. So that's not on table S. You don't see the word water anywhere on table S. So not a compound, the answer is B. So which statement describes H2O liquid and H2O2 liquid? Ooh, very careful, right? These are 2 different substances. All right, so both are compounds, true, that have the same properties. Not true, right? Peroxide is H2O2. That does not have the same properties as water. Both are compounds that have different properties. That's true. I'm going to circle it, but I'm going to check my other choices to make sure. Both are mixtures that have the same properties. Nope, they are not mixtures. Those are pure substances. It's a compound, so not mixtures. Which substance can be broken down by a chemical means? That is the definition of a compound. It's the opposite of the question above. So in this case, I'm looking for something that is not on table S, because the elements are on table S. So ammonia is not on table S, so I'm going to circle that one. It looks good. Antimony is SB. That's on table S. Aluminum is AL. That's on table S. Argon is AR. That's also on table S. So I have the 3 the same, 1 different pattern, and that's also an indication that I have my answer correct. So a mixture is made up of 2 or more substances. Remember, substances are elements and compounds. So if I have Br2L, that means bromine in its liquid phase. So that is not a mixture. So it has to be 2 or more elements, 2 or more compounds, or elements and compounds mixed together. So that's just an element, bromine. KBr is a compound. It's a pure substance. It's not a mixture. K is an element, and that is not a mixture. But if I have KBr in this AQ, the AQ is the most important part of this whole thing. That's telling you that it's a mixture. So then that's the answer. That's B. So the list below shows 4 samples, A, B, C, and D. Which samples are mixtures? Well, I know that I'm looking for that little AQ, right? I just learned that in my question number 5. So now I have AQ and AQ, so A and B. HClG, that means gas, that's a compound. NaClS, that's just solid. So that's also a compound and not a mixture. Which pair are classified as chemical substances? Substances are elements and compounds. So then that's going to be answer D. Mixtures are not substances. Substances means pure. Mixtures are not pure. Solution is a mixture. This is a solution, right? If you have a salt water saline solution, right? So that is a mixture. Okay, so which form of energy is transferred when an ice cube at 0 degrees is placed in a beaker of water at 50 degrees? Well, it's going to be thermal because that is heat flow. Remember, there's no such thing as cold, only the absence of heat, right? Or heat moving from high to low temperature. Alrighty, so there's nothing nuclear going on when you throw an ice cube in water. Definitely not something electrical going on, right? Let's get rid of those, right? Get rid of things that don't make any sense, right? Then at least if I have to determine between chemical and heat, then I can at least narrow it down by 50-50 and increase my odds. So a cube of iron at 20 degrees is placed in contact with a cube of copper at 60 degrees. Which statement describes the initial flow of heat? I know heat flows from high temperature to low temperature. So it's going to go from this copper at 60 to the iron at 20. Now let's look at our choices. Heat flows from the copper cube to the iron cube. Copper 60, iron 20. Yep, that's true. That's my answer. Double check. I'll prove the other one's wrong. Heat flows from the iron cube to the copper. Iron is 20, copper is at 60. Heat doesn't go from low to high. It goes from high to low. Heat flows in both directions. Nope. Always high to low. Heat does not flow. Heat always flows. There's always the flow of heat. All right, so which list includes 3 forms of energy? So thermal is a form of energy. Nuclear is not a form of energy. A nuclear power plant creates steam, which turns turbines, which makes electrical energy. So nuclear is not a form of energy. That's what they're trying to trick you with. Let's get rid of nuclear. Electronegativity. Have you even heard that word before yet? You haven't heard that word yet, so don't choose it if you haven't heard that word yet. Thermal, yes. Chemical, definitely a form of energy. Electromagnetic, yes. That is opposite charges, magnetism. So that's it. Remember, we haven't heard of electronegativity yet. Temperature, not a form of energy. Temperature is a measurement of kinetic energy, but it is not a form of energy itself. All right, so compared to sample 1, sample 2 contains, well, sample 1 is 100 grams, so is sample 2. Sample 1 has 10 degrees and sample 2 is 20 degrees. All right, so sample 2 contains molecules with lower average kinetic energy. Average kinetic energy means temperature. So let's read it again using that. Compared to sample 1, sample 2 contains molecules with lower average kinetic energy. Nope, sample 2 is 20 degrees. It's higher, so that's not it. Molecules with velocity, we don't even talk about velocity. So it's either more heat energy or less heat energy. So sample 2 contains, right, sample 2 is at 20 degrees. It contains more heat energy. All right, so number 12, right, you're going to definitely get one of these on your test. So a 10-gram sample of water, liquid water, at 23 degrees absorbs 209 joules of heat. What is the final temperature of the water sample? Okay, so it's absorbing heat. So the temperature is going to have to go up. So I'm going to eliminate those 2 choices right off the bat. And now I'm just going to do the math. So I have Q equals MC delta T. So then Q is joules. Who wears the joules? The Queen of England wears the joules. So Q, and so that is 209. And so according to reference table T, right, this is where the formula is. Do you need to memorize formulas? No, they're on table T. So M is for mass. So here's my mass. So then that is 10 grams. C is a specific heat capacity. That's going to be on table B of your reference tables. So that is 4.18. And now the change in temperature always has to be the final temperature minus the initial temperature. So the final temperature is what we're looking for minus the initial temperature, which is 23 degrees. All right, so now let's do the math. I have 209 is equal to 10 times 4.18 is 41.8 times x minus 23. All right, let's do it a little bit different. You can distribute the 41.8, or you can just get rid of the 41.8 by dividing like that. Boom. Do the same thing to the other side, so 41.8. So then I have 209, I have divided by 41.8, and that is equal to 5. Okay, so 5 is equal to x minus 23. So now I have to add, because I want to get rid of the 23, and add the 23. And so now 5 plus 23 is going to be 28 degrees. There's my final temperature, and it matches one of the questions. Awesome. Okay, if you can do that Q formula problem, you can do any of them. The other ones are all easier. This is very similar to question number 10, so I'm not going to go over it in detail. Exothermic is not a form of energy. Chemical is, temperature is not. Chemical, thermal, electromagnetic, yes. Chemical, nope, not nuclear, not falling for their tricks. Nope, not temperature, not falling for the tricks. Electrical, mechanical, both forms of energy, but not endothermic. Okay, we're getting there. All right, we have a 50-gram block of copper at 10 degrees is carefully lowered into 100 grams of water at 90 degrees in an insulated container. Which statement describes the transfer of heat, right? Transfer of heat is the same thing as heat flow, and heat is always transferred from high to low. So now I have to figure out which one's higher, which one's lower. I've got this block of copper is at 10 degrees and the water is at 90 degrees. So it's going to go from the water to the copper, right? So water to the copper, right? So then the water loses heat, okay, yep, to the block until both are at 10 degrees. Nope, if I mix something at 90 degrees and 10 degrees, they're not going to both end up at 10 degrees. All right, the block gains heat from the water. Yes, because the water is giving the heat to the block until both are at 90 degrees. Well, there's no way that that copper can get up to 90 degrees because the water can't transfer everything. There's got to be some heat loss to the system. The water loses heat and the block gains heat until both are at the same temperature that is between 10 and 90. Yes, that's what's going to happen. If I add in, a block of copper to the 90-degree water, that's what's going to happen. Okay. But the water gains heat. Nope, the water's at 90 degrees. It's going to lose heat. Okay, so then that makes that one false. The burning of magnesium. All right, we saw this in the lab that I did, right? The demo lab, right? That's my favorite. I love burning magnesium. So burning magnesium involves a conversion of chemical energy to mechanical. I didn't really make anything move when I lit that, right? Think about what happened when I burned the magnesium in the lab, right? We made a bright white light. So chemical energy to heat energy, conversion of heat energy to chemical energy or heat energy. So it's not going to be mechanical. So it's going to be chemical energy to heat energy. Okay. So what kind of energy, because of the light, right? There's a lot of heat with that bright light. So which kind of energy is stored within a chemical substance? Well, our stored energy is potential energy. We haven't talked about free energy, and we haven't talked about activation energy. Kinetic energy is related to temperature, so that's not it. The temperature of a substance is a measure of the average kinetic energy of the particles. Yes, temperature is average kinetic energy, not the average potential energy. You haven't even heard of ionization energy or activation energy yet, so don't choose those. Which temperature represents the highest average kinetic energy? Average kinetic energy is temperature. So let's try it again using the word temperature instead of average kinetic energy. Which temperature represents the highest temperature of the particles in a sample of matter? I'm looking for the highest temperature. 98K, 27C, 267K. I cannot compare Ks to Cs. They either have to all be Cs or all be Ks in order for me to figure this out. So I'm going to use my conversion. Kelvin is equal to the Celsius plus 273, which is on your reference table T. So I'm just going to convert the Celsiuses to Kelvin. So I am going to do 27 plus 273. So that's 300 Kelvin. And now I'm going to do the 12 plus 273. So that's 285 Kelvin. So I have 298, 300, 267, 285. This is my highest, so it's 300. Make sure if you have units that are different that you make them either all Celsius or all Kelvin. To go from Kelvin to Celsius, you subtract 273. You could have done this, you could have done that also and then compared them on the Celsius scale. Which term is defined as a measure of the average kinetic energy? I've said that a bunch of times already. Temperature. You haven't even heard about entropy yet. Potential energy is stored energy, and we haven't talked about activation energy. All right, which quantity is equal? This is why we did the metric conversions. So 50 kilojoules, right? So I have 50 kilojoules, and I want to convert it, it looks like, to joules. So I want to get rid of kilojoules and I want to go to joules, right? Kilo is 10 to the power 3. That means that you're going to either move the decimal place 3 places or you set it up as a conversion dimensional analysis or proportion. And so 1 kilojoule is 1,000 joules, right? Because that's what 10 to the power 3 means, 1,000. So then I'm going to go 50 times 1,000 is 50,000. So 50,000. But that's not one of my choices, darn it. But maybe one of these scientific notations might be my answer, but in scientific notation. So let's give that a try. So I need to put the decimal place right there, right? Because I need a number between 1 and 10. And now I need to figure out how many hops to get to the decimal place, which is down over here. So I'm going to go 1, 2, 3, 4. So it'll be 5.0 times 10 to the, since I hopped to the right, positive 4. And look, I have a match. All right, so careful with that one. That one's tricky. All right, so what is the equivalent of 0 Kelvin on the Celsius scale? So Kelvin is equal to Celsius plus 273, which is the formula on reference table T. So then what's the equivalent Kelvin of 0 Kelvin? So I want 0 Kelvin is equal to what Celsius temperature plus 273. Subtract 273, subtract 273. So 0 minus 273 is negative 273. Which temperature is equal to 120 Kelvin? So I have 120 Kelvin is equal to Celsius plus 273. So I'm going to subtract. I'm going to subtract 120 minus 273. That's equal to a minus, sorry, I think I messed up my calculator, sorry. So 120 minus 273 is 153, minus 153, sorry, minus 153. So number 23. A sample is prepared by completely dissolving 10 grams of sodium chloride in 1 liter of water. Which classification best describes this sample? Completely dissolving. When you completely dissolve, do you see anything floating around in the water? No. So that means everything's the same. You cannot look and see any visible. You can't see the salt. You can't see the individual. Everything's all the same. So then that's why I'm going to use my homogeneous, right? Because heterogeneous means different. So if I have heterogeneous, it means I'm going to see something different in that solution, and I don't. So it's going to be either a compound or a mixture. Well, if I have salt and I'm dissolving it in water, I've got 2 compounds here. So that's going to make it a mixture. So salt water is a homogeneous mixture. So table sugar can be separated from a mixture of table sugar and sand. So I've got two solids. I've got sugar and sand. One of these ways will help me separate sugar and sand, which would be the same way to separate salt and sand. So if I add sand and stir and distill, I'm not going to be able to get rid of anything. So if I add more sand, that's not going to work here, right? And distilling is to separate two liquids with different boiling points. So that doesn't work. If I add sand and stir and filter, then everything sticks in the filter, the sand and the sugar. So that's not going to work because I just am going to have sand and sugar still just stuck in the filter because it doesn't pass through the filter because sand and sugar are both solids. All right, so I'm going to eliminate that one. Actually, this one was not last year's Regents exam because it was canceled the year before. This is one of the most missed questions on that Regents exam because kids don't read carefully and they don't think and apply their logic skills. So now, if I add water, okay, so if I add water to sugar and sand, what happens? Okay, the sand gets wet, but the sugar is going to dissolve, right? We've had sugary water before. Okay, so water and stirring, those work. Now I just got to decide, am I going to, after I add the water, do I distill or do I filter? Well, if I distill, that's just boiling. And so I'm not going to end up, I'm just going to end up having sand and sugar at the end and then water separate, but that's not what I want. I want the sand separate. And so if I have the water stir and I filter, now that is going to separate because the sand is going to get filtered out and then the sugar water, right? So I can separate the sugar and the sand by adding water, stirring, and then filtering. All right, so distillation is the process used to separate a mixture of liquids based upon different boiling points because they boil at different temperatures, so you're able to distill them. And I think that's, oh, sorry, a couple more questions, sorry. Okay, which statement describes this reaction? So here's this reaction. I can say it's endothermic and energy absorbed, exothermic. So then basically I have to decide if it's endothermic or exothermic and is energy absorbed or released. So if this is energy and I start here, these are my reactants with A, right? Here's A and B, and here I'm making C. Am I going up in energy or down in energy? So it looks like energy is kind of going down here. So it's going to be exothermic, right? Because this is going to be releasing heat, right? I had this much energy and now this much energy at the end. That means that this amount of heat had to leave, right? I had to leave, this heat had to leave. So exothermic, so it's not endothermic. So I'll just draw you a little picture. So an endothermic would look more like this, right? This would be endothermic. You absorb, so potential energy is here. You end up higher energy, you have to have taken in energy. That's endothermic. So this is exothermic. Exo means out or release. Okay, so then that's going to be choice D. So number 27, a 15.1 gram sample of metal absorbs 48.75 joules of heat. Its temperature increases 25 Kelvin. What is the specific heat capacity of the metal? Well, anytime I have anything with joules, I say the Queen of England wears the joules, so I have to use my Q formula. Q equals MC delta T. So then Q is equal to it. I'm solving for the specific heat capacity, so that's going to be my X. So Q is 48.75, right? So here's Q. And here's the temperature increases, so then that's my change in temperature. So there's the change. What is the specific heat capacity? And here's the mass. So that my mass is equal to 15.1. The specific heat capacity is what I'm looking for. And the temperature changed, by 25 Kelvin, right? It increased 25. That is the change. You don't need to subtract temperatures because they told you what the change is. Now I just need to do the math. So 48.75 is equal to, I'm going to do 15.1 times 25. So then that's going to be equal to 377.5 times x. Divide by 377.5 to get rid of that. Divide by 377.5. So now I need to do 48.75 divided by 377.5, and that equals to, it equals, so the C equals 0.129139 and some other numbers. So then which one does it match? Choice A. So number 28. An 80-gram sample of water at 10 degrees absorbs 1,680 joules of heat. What is the final temperature? Again, another final temperature question. So Q equals MC delta T. And so the Q in this case is 1,680. The mass is 80 grams in the question. The specific heat capacity from table B, 4.18. And now the final temperature minus the initial temperature, which is 10 degrees, right? So final minus initial. Now I just got to do the math, right? So I'm going to do 1680. I'm going to do the 80 times the 4.18. So 80 times 4.18. So then that is equal to 334.4 times x minus 10. Let's get rid of that 334.4. So divide by 334.4. So now I'm going to do the 1680 divided by 334.4 equals. So I have 5.023 is equal to like x minus 10. Add 10 to get rid of that. Add 10. So I'm at 15 point something other degrees. So then that's choice B. All right, so the number 29. When 200 grams of water cools from 50 to 25 degrees Celsius, the total amount of heat energy released by the water. So here I have some joules. Oh, interesting. Kilojoules, and I have joules. All right, I may need to have to pay attention to that. I am going to just I'll just do, since I'm running out of space here, I'll do 29 right over here, and then I'm going to erase some and do 30. Okay, so I have Q equals MC delta T. Actually, hold on. Let me just do erase here. Okay. I'll just do like Q equals MC delta T. There's my formula. I have 200 grams of water, and it cools from 50 to 25. So this is it's M, C 4.18, and now it cools from 50 to 25, right? So that's final minus initial. So then it's going to be minus 25. And don't worry, they're telling you released, so you're going to be able to just drop the negative. So now I just have to multiply 200 times 4.18 times 25. So then that is equal to 20900 joules. Okay, so I have 17 joules. Can't be 17 joules, can't be 34 joules. Now I just need to see, is it going to be the kilojoules? Is it 42? No. Could it be 21 kilojoules? Well, kilo is 10 to the power 3. So that means I need to move the decimal point 3 places to the left. You divide by 1,000. So then move the decimal place 1, 2, 3 places. So 20.9. They round to significant figures. So that's going to be 21. All right, so that's even trickier. That's a pretty tricky question. So 30, you have to pay attention to those details, right? You had to pay attention to those kilojoules. All right, last one. The temperature of 100 grams of water changes from 16 to 20 degrees Celsius. What is the total number of joules of heat energy absorbed by the water? So again, Q equals MC delta T from your reference table T. And we're looking for Q, and the mass is 100 grams. The specific heat capacity of water from reference table B, 4.18. And now I have to go from 16 to 20. And so then 20 minus 16 is 4. Okay, so now I'm just going to multiply a 100 times the 4.18 times 4, and that's equal to 1672. Okay, I know what's going on in this question. Okay, so my answer is right, but I'm not seeing it there. So what do? You pick the one that's closest to your answer. So that's going to be this one right here. And now the reason why this isn't working out exactly the way that you want is for one reason and one reason only. In your reference tables, right, are labeled 2011 edition. Prior to 2011, they were using C equal to 4.2 instead of 4.18. So if I do this with 4.2, it should match. So this is an old question from the question bank prior to the 2011 update of the reference table numbers. So if I did 100 times 4.2 times 4, that's going to be equal to 1680 joules. Okay, so that's just using 4.2 instead of 4.18. All right, that's it. That's all of the answers to those homework questions. And remember, the other review sheet with the matter section and the energy section, and I made a whole nother Zoom meeting, myself annotating and going through all of the questions. So that is going to help you study for your test, because you can't just rely on the internet for your tests, because you know that for this year, due to COVID, it's open notes. But you don't have infinite time for the test. So you really should know your material as well. All right, so you're not cheating me if you directly cheat. You're really just cheating yourself, because you still need to know the content on Regents Day, because you can't bank on it being canceled. All right, so I'm going to stop my share. I'm going to stop my recording, and I hope you all are having a nice and happy, safe Halloween.